Right now, somewhere, in the last hour, you've done something you never once had to learn. Your stomach growled, and before you'd even decided anything, you were already walking toward a fridge. Nobody taught you that. There's no manual for it. Hunger just arrives, and your body acts on it like it's the most obvious thing in the world. Here's the strange part. Ask yourself what you're actually supposed to eat, not what a diet book says, not what's trending this year, and you'll notice you don't really know. We're the only species that seems to have lost the instruction manual for its own diet, then spent the last few decades arguing about how to rewrite it. Which is why in 2010, a researcher named Amanda Henry did something almost nobody had thought to try. She scraped the hardened plaque off the teeth of Neanderthal skeletons from Shanidar Cave in Iraq and Spy Cave in Belgium, fossilized dental calculus, tens of thousands of years old, and looked at it under a microscope. Trapped inside were starch granules, plant starch, from cooked food. That single detail broke a story scientists had been telling for a century. The old assumption was simple. Early humans were meat-first, opportunistic hunters who ate plants only when they had no better option, the so-called meat made us human idea. And it wasn't wrong, exactly. Hunting mattered enormously, and animal fat and protein almost certainly shaped our brains in ways plants alone couldn't. That part holds up. But the plaque told a messier story. Root vegetables, grains, legumes, cooked and softened long before agriculture existed, not snacks, staples. And once researchers started checking other sites, the pattern didn't hold together the way anyone expected. What early humans ate in Iraq had almost nothing in common with what they ate in coastal South Africa, or the highlands of Ethiopia, or the river valleys of Belgium. So here's the thesis this episode is actually built on. There was never one ancestral human diet, not one macro split, not one ratio, not one set of foods we evolved to eat. What evolved wasn't a menu, it was the ability to eat almost anything and figure it out fast wherever you landed. That's already a strange enough idea to sit with, but the deeper you go into what's preserved in fossilized plaque, ancient stomach contents, and even fossilized human waste, the stranger it gets. Because the real question isn't what they ate, it's how something as automatic as your next meal became one of the most adaptable tricks evolution ever pulled off. Here's why this actually matters more than a trivia question about ancient menus. Diet isn't just fuel, it's the single biggest lever evolution had to reshape a body, and it used that lever on us harder than on almost any other primate. Consider the human gut. Compared to a chimpanzee's, ours is short, simple, low maintenance, almost embarrassingly small for how much energy we burn. Chimps carry large, fermentation-heavy colons built to slowly break down huge volumes of fibrous plant matter. We don't. Somewhere along the way, our ancestors traded a big gut for a big brain, because both organs are metabolically expensive, and the body doesn't get to keep both at full size for free. That trade only works if you're eating food dense enough, cooked, processed, calorie-rich, to make a smaller gut worth the risk. Which means, in a very literal sense, whatever your ancestors figured out to eat is the reason you're capable of reading this sentence right now. Your brain is quietly burning something like 20% of your resting energy today, this minute, on a gut evolution bet millions of years old that plant roots and cooked meat could reliably deliver enough calories to keep paying for it. You didn't choose that trade. It was made for you, long before you existed, by ancestors solving a problem you'll never have to think about. That's already unsettling if you sit with it, but it gets stranger because the trade wasn't uniform. Different human populations made different versions of this bet in different places, with wildly different foods on the table, and somehow all of those bets paid off enough to produce you. The old story treats early human diet like a single fixed answer waiting to be discovered. Find the right cave, find the right teeth, get the final word. But every new site researchers dig into complicates that picture instead of simplifying it. And if the answer isn't singular, that raises an uncomfortable question the rest of this story has to answer. If there was no one right diet even 50,000 years ago, what exactly were our bodies adapting to? The wrong assumption is easy to spot once you say it out loud, that early humans were one population, eating one diet in one kind of place. Say, caveman diet, and most people picture the same thing, a guy with a spear mostly eating mammoth. That image comes from real science, but borrowed science. It leans heavily on sites like Olduvai Gorge in Tanzania, where cut-marked animal bones convinced researchers in the 1960s that meat eating was the defining leap in human evolution. And to be fair, those cut marks are real, and they matter. Around 2.6 million years ago, something using stone tools was slicing meat off carcasses in East Africa. That's not in dispute. The mistake was extrapolating outward, assuming that because meat eating showed up early in one region, it must have been the universal engine of human evolution everywhere for everyone, always. It's a little like finding one very good pizza place in one city and concluding the whole country must eat the same thing for dinner. Here's where it gets stranger. When researchers looked at isotope signatures, a chemical fingerprint left in bone and tooth enamel that reveals what an individual actually ate over years of their life, the picture fractured immediately. Neanderthals in parts of Europe show isotope ratios nearly identical to wolves and hyenas, heavy meat eaters, some of the most carnivorous hominins ever documented. But at Tafarolt Cave in Morocco, isotope analysis of human remains from around 15,000 years ago shows a diet built substantially around acorns and wild pulses, nutty, plant-forward, almost unrecognizable next to their European cousins. Same species, same rough time period, wildly different tables. That doesn't erase the meat-eating story. It just means meat-eating was never the whole story. It was one regional strategy among several, and treating it as universal is where the wrong assumption quietly took hold. Which raises the real question the next section has to answer. If diet wasn't fixed by biology, what was actually driving these choices? The mechanism underneath all of this isn't really about food at all. It's about a switch evolution flipped in how flexible our bodies are allowed to be. Most mammals are metabolic specialists. A koala's gut is essentially a fermentation vat built for eucalyptus and almost nothing else. Feed it something different, and it can genuinely struggle to survive. Evolution optimized it for one food source so thoroughly that the option to switch was closed off entirely. Human evolution did something closer to the opposite. Instead of specializing our digestive system for one food, it specialized our behavior for finding food, period. Any food, wherever we ended up. Researchers call this dietary plasticity, the capacity to shift what you eat, sometimes drastically, without needing a new body plan to do it. Our teeth stayed general purpose instead of narrowing towards shearing blades like a cat's or grinding mills like a cow's. Our gut enzymes stayed broadly tuned rather than hyper-specialized. What evolved wasn't a diet, it was a toolkit for improvising one, on the fly, anywhere on Earth. That toolkit had an enormous quiet assist: fire. Cooking doesn't just make food taste better, it pre-digests it. Richard Wrangham, a primatologist at Harvard, has argued that cooked food delivers dramatically more usable calories than the same food raw, because heat breaks down tough plant fibers and denatures proteins before your gut ever has to do the work. A cooked potato hands your body calories almost effortlessly. A raw one makes your gut fight for every bit of it. That means fire wasn't just a survival tool, it was a second stomach, sitting outside your body, doing digestive labor before food ever touched your mouth. Every population that mastered it unlocked a wider menu than the one before it, which is exactly why the diets we're about to look at get so wildly different from region to region, and why the gap between them is about to matter a lot more than it first appears. This is where the evidence stops being theoretical and starts getting specific. And it starts, again, with Amanda Henry's dental calculus work, because it opened the door for a wave of sites that all told different regional stories. At Shanidar Cave in Iraq, the starch granules trapped in Neanderthal teeth included barley and legumes, some of it showing damage patterns consistent with cooking, not raw grazing, but deliberate processing. That's roughly 46,000 years before agriculture existed. These weren't farmers, they were foragers who'd figured out how to make wild grain edible long before anyone thought to plant a seed on purpose. Move to Border Cave in South Africa, and the evidence shifts underground, literally. In 2020, researchers led by Lynn Wadley identified charred remains of Hypoxis angustifolia, a wild rhizome, essentially a starchy underground root, dated to around 170,000 years ago. That's one of the oldest known instances of a starchy plant food being deliberately cooked by anyone, anywhere. Not meat, a root vegetable, roasted in a hearth, 170 millennia before the pyramids. Then there's the Ohala II site in Israel, on the shore of the Sea of Galilee, dated to about 23,000 years ago, so well preserved by waterlogged, oxygen-poor soil that researchers recovered actual charred seeds, wild wheat, barley, even early evidence of what looks like small-scale cereal processing, grinding stones included. 2,000 years before anyone would call it farming, someone at Ohala II was already doing something that looked remarkably like a harvest. Here's the thing, none of these sites agree with each other, and that disagreement is the actual discovery. Line them up and the diversity gets almost comedic. Iraq, wild grains and legumes, cooked. South Africa, starchy roasted rhizomes, underground and unglamorous. Israel, proto-harvested wild cereals ground into something edible. Belgium's Spy Cave, heavy reliance on water lily roots and wild mushrooms alongside meat. Coastal sites like Pinnacle Point in South Africa, shellfish harvested with tidal precision that implies people were tracking moon cycles to know when the beach would feed them. 5 sites, 5 continents worth of strategy packed into the same rough window of prehistory. If there were a single ancestral human diet, these sites would look like variations on a theme. Instead, they look like 5 different species solved the same problem in 5 unrelated ways, except it's the same species doing it again and again, everywhere it went. That already reframes the whole story, but it gets stranger still, because these weren't just varied, they were responsive, changing generation to generation, as climates shifted, as coastlines moved, as ice ages tightened the available options. At Classy's River Cave in South Africa, isotope evidence shows diet shifting measurably between glacial and interglacial periods at the same site, meaning the same lineage of people living in the same caves ate meaningfully different diets depending on what a colder or warmer world handed them. That's not a species with a diet, that's a species with a strategy for never being without one, and it's about to raise a much stranger question than what did they eat. It's going to ask what happens to a body and a whole population when that strategy runs into a food source nobody was ready for. Here's the part almost nobody expects, and it doesn't come from a new site. It comes from looking again at the evidence we already had and noticing what it does to a single person. Go back to Shanidar Cave. One of the individuals recovered there, catalogued as Shanidar I, was an adult Neanderthal who lived to what was, for his time, an extraordinary age, probably somewhere in his 40s or 50s. His skeleton shows a healed, withered right arm, likely amputated or atrophied from injury, along with signs of significant hearing loss and old healed fractures throughout his body. He could not have hunted effectively. He may not have been able to chew certain foods without help. And yet he lived for years after those injuries, which means someone was feeding him. Someone was choosing the softer, easier to process foods, the cooked starches, the pounded roots, and making sure he got them. His dental calculus, the same kind of evidence that revealed cooked barley at his site, also shows the wear patterns of a diet adapted to what a damaged mouth could actually manage. That's not a fact about starch anymore. That's a fact about care. A diet flexible enough to include soft, cooked, easily digested plant food wasn't just a survival hedge against bad hunting seasons. It was, in at least one documented case, the thing that let a badly injured man stay alive inside his community for years. The same dietary plasticity that let humans colonize 5 continents also, quietly, made room for someone who couldn't keep up.
Now widen the lens outward from Shanidar 1 to his whole group, then outward again to what this means for the species. If diet in this era wasn't fixed but responsive, shifting with injury, age, climate, coastline, then the food itself was never really the point. The point was the decision-making layered on top of it. Who eats what, who gets fed when they can't provide for themselves, what gets cooked longer, mashed finer, saved for later. That's not biology anymore. That's something closer to what we'd now call culture, showing up in tooth plaque 50,000 years old. And if that instinct, feed the ones who can't feed themselves, is old enough to be written into a Neanderthal's dental record, it raises an uncomfortable question about where exactly the line sits between surviving on whatever's available and something that looks a great deal like compassion. That line is a lot blurrier and a lot older than most people assume.
Which brings this forward into something you've probably felt personally, maybe even this week: the modern argument over what humans are supposed to eat. Walk into any bookstore's health section and you'll find it laid out as a fight. Paleo diets insisting on meat-heavy, grain-free eating because that's supposedly what our ancestors evolved to do, up against plant-based advocates arguing the opposite, that we're built for a diet closer to tofferalts, acorns, and pulses. Both sides cite evolution. Both sides cite ancestors. Both sides are working from a real site, a real study, a real skeleton. And both sides are quietly cherry-picking one chapter out of a much longer, much messier book. The Shanidar Neanderthals eating cooked barley and the isotope-heavy carnivores of Ice Age Europe were the same species, sometimes overlapping in time. Neither diet was the human diet. Both were correct answers to different local problems. The modern version of that same skill, regional adaptive eating, still exists. It's just been relabeled. It's why a diet built around fermented soy and rice sustains entire populations in parts of East Asia, while a diet built around dairy and wheat sustains populations across parts of Northern Europe, and both produce people who are, by any meaningful measure, thriving. The difference between then and now isn't the flexibility. We still have it, biologically, mostly intact. The difference is that we no longer have hunger, climate, and coastline doing the choosing for us. Early humans adapted diet to environment because they had no other option. We now adapt environment to preference, shipping avocados to places avocados have never grown, because we can. That's the quiet contrast worth sitting with. The same evolutionary toolkit that let a Neanderthal in Iraq eat barley and a forager in South Africa eat roasted rhizomes is still running in you, right now, capable of adjusting to nearly anything you hand it. What's changed isn't the machinery. It's that the machinery used to answer to necessity, and now it mostly answers to choice, which means the diet debates raging in your feed aren't really a modern invention at all. They're an old argument, just missing the part where the environment used to settle it for you. So, go back to that moment your stomach growled, before you'd consciously decided anything, and you were already halfway to the fridge. That instinct feels automatic, because it is, but it's also inherited in a very specific sense. It's the same instinct that sent someone at Border Cave digging up a rhizome 170,000 years ago, and the same one that had someone at Shanidar quietly preparing something soft enough for a man with one working arm to eat. You don't have to choose between meat and roots, between paleo and plant-based, between one correct ancestral answer and another, because there never was one correct answer. There were thousands of good enough ones, built fresh in every valley, every coastline, every cave, by people solving the same problem you solve without thinking about it 3 times a day. What you actually inherited isn't a diet. It's the ability to never be stuck with just one, a flexibility written into your gut, your teeth, your enzymes, tested across ice ages and coastlines, and injuries that should have been fatal. And it worked well enough every single time to eventually produce you, reading this, probably a little bit hungry right now. Early humans never agreed on what to eat. That was never the point. The point was that they never had to.